Hey all, welcome back to my channel. So today I will be covering another crucial topic in the world of large language model, that is tokenization. Before I cover what exactly is this, let me set up some context. So whenever you feed a model with any input, let's say in the form of text, it doesn't understand those words. Basically, it sees numbers. So whenever you feed your model, let's say with a very basic sentence of cat sits on the mat, it will appear to the model as a series of some numbers, where each word will correspond to certain number, right? These numbers are technically the position of those words present in the model vocabulary during the training phase, which I will cover going forward. Now you might be imagining, why not just assign a number to every word? Well, is that so easy? Well, with countless languages and new words popping up daily, it might not be feasible for the model to include all the words, all the languages in its vocabulary and assign a unique ID to it. It would be like trying to count grains of sand on a beach. So tokenization is a clever workaround of solving this new or unfamiliar words, unfamiliar languages, because it breaks word into smaller, manageable units that might or might not be equivalent to a word, right? And these small, manageable units are actually mapped in its vocabulary during the training phase. So if we surprise a model with, let's say, a very unfamiliar word of, let's say, AI pods, which is my recent name of the which is the name of my recent initiative, the model can efficiently process it with the help of tokenization process, because it splits it into small manageable units like AI or pods, or AI pod and S separately, right? Depending upon how the vocabulary is mapped, right? So technically, these numbers which you see in the below of each of these unit are actually the position of those particular segment in its vocabulary, right? So tokenization can handle any unfamiliar word, any unfamiliar languages by segmenting the continuous strings of characters into some meaningful units, which are mapped to its vocabulary during the training phase. Now let's now let's see how does it impact on the cost. Another important concept. So more tokens leads to higher computation, right? And higher computation will eventually lead to the higher cost, right? So on an average, generally on an average, the number of tokens is about 4/3 of the word count when the language is familiar to a model. But when the language is not familiar to the model, like let's say ChatGPT 3.5, if not is familiar with Hindi language, then it might require a lot of tokens, a lot of computation, and eventually a lot of cost. For example, I have attached a screenshot here where I have calculated a similar sentence of 4 words in English and Hindi language, right? GPT 3.5, GPT 3.4, which is already trained in English language, is it breaks each of these words into tokens, which is equivalent to more or less each word, right? And eventually it leads to number of tokens of 5. Whereas in Hindi language, since it is not familiar with these words, so it breaks these into multiple tokens, right? So which leading to the number of tokens of 28, which is like more than 5 times of what it was in English language, right? So model has to compute a lot here, and eventually the cost will rise up in the case of unfamiliar language. So now you understand, you've got a glimpse of how tokenization is a very critical concept in the large language models world, right? To control the cost. It's like having an unsung hero that helps model make sense of any messy, beautiful language. So if you found this useful, if you found this helpful, don't forget to like and subscribe for AI explainers. Thank you.